Wow, I am humbled to see so many of you in this room with this kind of weird title and everything. My name is Ola Bini. I work for a consultancy called ThoughtWorks, and my title there is Computational Metalinguist, which is kind of a joke because it turns out that at some point in our careers as developers, you usually kind of end up doing quite a lot of stuff. You do tech leading, you do architecture, you do development, you go talk at conferences. So kind of summing up all of those experiences in one thing becomes really tricky. So at ThoughtWorks, most people choose something random to put on their business card. And that's what I do for a living. So this talk is about polyglot programming. It's about some of the patterns that people use. It's about why you would do it, how you can do it, and maybe also some of the things that you shouldn't be doing. Most of the examples here will be using JVM languages because, as I will mention later, I think that the JVM is the best place to do this kind of programming right now, and that's also the place where I have the most experience. So my background is actually mostly in the Ruby world. I'm one of the core developers for GRuby, which is kind of an example of something that is very polyglot in itself. The whole goal of GRuby is to allow you to use both Java and Ruby in the same place. But I also do lots of consultancy, developing applications in both Ruby and Java, C#, and all kinds of other languages. I'm kind of a omnivore when it comes to languages in general, so yeah. So we will see quite a lot of different language examples. Most of them will run on a JVM. Okay, so let's begin with the polyglot definition. What is a polyglot? There are several different definitions for this. Some of them are more interesting than others. So this one is probably the most pertaining to what we're going to talk about today. Polyglot, containing composed of or written in several languages. Or a mixture or confusion of languages. I would say that both those exemplify some things that sometimes happen. Now, why would you ever want to do polyglot programming? Well, it turns out that there's lots of really good reasons for it. The first one has to do with verbosity. How many here do Java programming as a day-to-day job? Okay, that's actually fewer than I expected. That's about 60 or 70%. C#? Okay, everyone who haven't raised your hand yet, what's the main language? Perl, Ruby, and JavaScript. Okay, so that's good. It's a good variation here. Now, these languages are different, obviously. Some of them require you to say quite a lot of stuff to get things done. That's why I started with Java. Java has this thing where you actually have to repeat what you're saying lots and lots of times to actually get anything done. Now, this is on purpose in terms of Java. In fact, James Gosling has said on numerous times that several of the syntax elements of Java were designed that way because he wanted to write a language that was easy to understand for people not used to it. It's something that would be easy to write for people not very experienced. So he requires you to repeat stuff in order to tell the compiler that you actually meant what you said the first time. Some of that stuff is going away in Java 7, incidentally. Like, you don't have to say list string x equals new array list string. You can actually say just list string x equals new array list. And then have kind of empty angle brackets, which is called the diamond operator. So Java is losing some of its syntactic heaviness, but the fact is still that you have to say a lot of stuff to get things done in Java. Sometimes that's warranted. Sometimes it gives you some more speed. But in many cases, speed isn't the most relevant thing. The most relevant thing is to express what you are trying to solve, express your business problem. Some of my friends talk about this as the difference between ceremony and essence. You talk about the essence of the problem and the ceremony you have to do to actually get it to execute. So in Java, you have quite a lot of ceremony. And a big part of ceremony is not only the syntax of the language, it's also stuff like compilation. If you've ever done professional C++, you know that compiling C++ can take quite a long time, and that's a real that's really only ceremony. It doesn't really contribute anything at all to solving the business problem. You just need to do it to get it to run, to actually solve your business problem. So that's one of those things. Different languages working in different paradigms can give you different balancing scales on ceremony versus essence. Of course, performance is also a factor. Slow turnaround and compile time can definitely make a difference. But the thing that I really care about the most is the abstraction level and kind of expressivity of what you're doing. If you can express your business problem at a higher level, then it might be easier for you to talk about it, to think about it. So I'm going to talk about some examples of that in a while. The final example of why you would do polyglot programming is a very simple one. Libraries. In many cases, you actually, like in the case of Ruby and Java, you want to use a library that just doesn't exist or is really annoying to use from the other language. Like, for example, say you're writing a Rails application. And that's really fantastic. You're moving really agile. You're showing your customers new code all day around. And then you find out that a business requirement is to connect to this really obscure database. And the only way of interacting with that is to use the JDBC interface. And at that time, it's really good that you can actually use this on top of GRuby because you can use any JDBC interface from GRuby to run with Rails. And those kind of situations happen quite often. In fact, that's kind of why ThoughtWorks started doing GRuby for real. We started finding more and more situations where we just couldn't satisfy our requirements for integration with the regular Ruby stack. Because integration is kind of, as a bespoke software developer, integration is 90% of every application you do. You always have to integrate most of the time with legacy systems. So these are kind of some of the reasons. And to look at this another way, there is this thing in linguistics called SapirWhorf. It's a hypothesis, and it's mostly been proven to be false, at least in the strong version for human languages. The SapirWhorf hypothesis says basically that the languages you speak shape what you can think. It decides what you can think. If you've read 1984 Newspeak, that's a good example of the strong hypothesis of SapirWhorf, where you can't think about revolution if you don't have a word for it. As I said, most linguists think that this is now false, at least in the strong version, but there are indications that the weak version that just says that the language we speak impacts what we think about is true. There are definitely some examples in languages like, for example, Aboriginal languages. Most of them, Australian Aboriginal languages, you actually refer to things, directions, with absolutes. You always say absolute directions. You never say relative directions. So you never say left or right or above or beyond or under. Instead, you said this thing to the northeast of me, etc. And it turns out the people who speak these languages are much, much better at knowing what direction they're heading all the time because they have to keep track of it, and so on. So SapirWhorf is like still undecided. By the way, this is a very common example of SapirWhorf. Eskimos have lots of words for snow because they need more words for snow because there is more snow around them. This is a myth. It's totally, completely false. And it was one of the examples that were kind of used initially to prove that SapirWhorf was true. But it's actually just based on a wrong understanding of the way Eskimo languages work. Incidentally, programming languages seem to have more of this way of thinking than natural languages. And there are several people that have kind of been thinking about SapirWhorf and how language relativity works in terms of programming languages for a long time. One example is a paper by Iverson, Notation as a Tool of Thought. Iverson created APL a long time ago. There are some other examples. Paul Graham has this very well-cited essay called the blob paradox. And the whole idea of the blob paradox is if you program in a language called blob, then you will look at all other languages that seem inferior to yours and just look down on them, and because you know that your language is better, but you can't look up the scale Because when you look up the scale at languages that are more powerful, you won't see more powerful things. You will just see weird things that don't seem to really add anything to your understanding, because you don't understand how those powerful features are used. So, for example, if you're a Java developer and you look at Haskell and you try to understand monads, most Java programmers really don't understand monads, which is fine, but they don't really understand how they make Haskell a more powerful language either, which is kind of a shame. Ruby, actually, Mats, the creator of Ruby, says that one of his main inspirations for the language was a novel called Babel 17, which has as one of the main premises that SapirWhorf is true, completely true, and is working. And it's a science fiction novel. I was kind of, his thinking around Ruby was shaped quite a lot from this kind of idea. And finally, Steve Yegi, a while back, he made a joke about, if you're math or comp sci persons, you know that recursion and iteration is actually equivalent. So he made a joke about the fact that they've now found proof that there is a difference between recursion and iteration, and that's because you can use recursion to totally stump people during an interview. If you programmed in BASIC in the 70s, you didn't have recursion in your language, but you did have iteration. And explaining recursion to a person that's not actually used it in a language is fairly tricky. So, polyglot. As it turns out, I would guess that most people, probably all of you, are already polyglot programmers to a degree, no matter if you're doing that consciously or subconsciously, because we have CSS, we have HTML, we have SQL, we have JavaScript, we have XML. Every XML they like to use is, to a degree, a language. How many of the Java people use Ant? Okay, that's not too many, actually. Don't say that the other people use Maven. I'm sorry about that. So, as it turns out, Ant is actually Turing complete, which means that you can painfully, but you can do most things in it. Now, several of these languages are not Turing complete, but they're kind of approaching. There is this thing called the Turing tar pit, which says that most languages, or smaller languages, configuration languages and so on, have a tendency to move slowly towards Turing completeness. Because it's one of those things that is just so easy to move towards. It is very, very easy to fall into the trap of just adding one more thing. And Turing completeness is really easy to get in a language. So you don't really need that much stuff. Okay, so that was kind of the intro to polyglot programming. How do you so the first step in being conscious about doing polyglot programming is actually adopting a new language. So how do you go about it? Well, I would say the first thing you need to do is to be very careful. If you are going to do polyglot programming on a real project, you probably need to be careful with what language you chose. Be really strategic about it. Think about how you're going to use it, why you're going to use it, what benefits, what side effects it's going to have on your organization. And I'm not saying, so one of the most common things that you hear from companies is that, no, we have standardized in Java, we can't use any other languages. Even though you probably have about 20 languages floating around already that the CXO don't really know about, because everyone is scripting in awk and sed, and they're using Perl for some things, and they're using a sendmail configuration. And I mean, you have all this stuff floating around that you don't really think about. But if you're going to build a business application, you probably should think at least about how you're going to handle onboarding new people, for example, how you're going to do integration between languages and so on. As an example, Google has this policy that they only allow 4 main languages. They allow C++, Java, Python, and JavaScript. And that makes it much easier for Google to handle all these things because their infrastructure is geared towards these languages, and they know how to handle them. They have very, very good language specs and documentation for them. I mean, when it comes to JavaScript and actually, when it comes to several of those languages, they have people who've been implementing compilers. Some of them have implemented and defined the language. They have GRuby right now, for example. Oh, they have Gosling, for that matter. So I mean, they have been very careful and strategic about their language use. They specifically choose languages that give them several different capabilities. One thing to note when you adopt a new language, my colleague Martin Fowler calls this the improvement ravine. When you start learning a new thing, you will get worse. Your productivity will sink. But then slowly you will kind of get upwards again. And that's fine. You have to learn new syntax and new libraries. But notice that semantics, usually, if you pick up a new language, you do it for a specific purpose. So if you pick up Haskell, you will spend some time understanding the thinking behind it, but it's usually the libraries that take the longest. The leverage of using a new language, usually, if you choose the right language, that is, the leverage should come quite quickly after you've kind of gotten over the initial thing. If you're good software developers, learning a new language shouldn't take more than a few weeks. And to be honest, I find once you've done this for a while, learning a new language is not very different from learning a new framework. It's really on the same level of complexity most times. So how do you put together an application that kind of builds on different languages? Well, I'm going to look at some anti-patterns that usually happens later. But the way I like to look at this in an idealized way, and this doesn't really happen in a real way, but you can think about it this way. I generally try to think about an application as having a small, stable layer. It should be really small most times. Then you have a larger dynamic layer, and then finally a domain layer. And the purpose of these things is basically the stable layer provides infrastructure services. It provides the core kernel services. If you think about it as an operating system, it is basically the kernel. The dynamic layer you can think about as the standard libraries that lies around it. And then finally, the domain layer is the business logic. One way you can do this is, for example, having a small Java core API, some Ruby running on top of that, and then business-specific DSLs. And for an example of this architecture is basically all GRuby on Rails applications, where you have Tomcat or whatever your Java web application container is, and the JDBC stuff down here. Then you have the Ruby on Rails part, and then finally, much of the application becomes basically a business DSL for implementing solving your problem. And you can also kind of mix and match depending on what you want to do. I tend to believe that statically typed programming languages, let's see how to say this politely, they should be restricted in use for when you really need them. They bring too much complexity, and they bring too much ceremony in terms of build times and type checking and other things that kind of get in the way of getting stuff done. So I usually want to minimize the use of a statically typed language. I tend to believe that the closer you get to the business layer, the more dynamic your language should be, and the more focused towards your application. So this is why I want to put like general dynamically typed languages in the middle, but then a DSL that is exactly geared towards your business domain at the top. So that's kind of the one way of organizing things. As I said, there are other ways of organizing that usually happens if you don't do this strategically. But before we get to that, I would like to talk about some other ways that you can kind of either get started with it or use polyglot programming to kind of gain leverage. The first thing, and this is one of those gateway drugs. There are two gateway drugs to polyglot programming, which is testing and building. Both of these are really good because they improve the quality of your project in different ways. They make you go faster, but you don't ship it, so you don't get the problem of having to deploy things in a different language and convincing your organization to do it and so on. Testing specifically is something that I really like, especially in terms of if you're stuck with Java, for example. Testing Java code using another language like Scala or Clojure, Ruby, GRuby, gives you leverage because you can write more tests. The testing frameworks are usually more advanced, give you more capabilities. You usually can write tests faster and it makes it easier to do things like TDD. And the Java integration in any of these languages make it extremely easy to work with them. There are definitely some examples of frameworks that are coming around to do this really easily. Like Cucumber is a framework for doing BDD, behavior-driven development, where you basically separate the specification of the test into plain text or something almost plain text that you can talk to your business analyst or the business person about it. But at the same time, it can be executed. But the back-end execution maps to the plain text in such a way that you can actually implement that in different languages. Now, the standard Cucumber distribution actually uses Ruby, but as like Helisoy, the creator of Cucumber, he has also created a Cucumber version that runs under GRuby, which means that, and he's also kind of added things so you can do step definitions in about 12 or 15 JVM languages. So he has even support so you can write step definitions in Java if you want to do that, but you can also do it in GRuby or Scala or Clojure or Ruby. So that's a really good example of something that works quite well. Since most of these dynamic languages, Scala shouldn't be there if I talk about dynamic languages. Most of them don't require compilation, which means that you can run the test quicker. The tests become more manageable, and you can also use libraries. Like RSpec is a good example. I really like working with RSpec. I've personally done several Java projects where I have tested using GRuby and RSpec, testing the Java code, and that works really, really well. But then you have some more interesting approaches that haven't really percolated into the mainstream of Java development yet. Haskell has this thing called QuickCheck. Is there anyone who has heard of that? Okay, that's actually a fair amount of people. QuickCheck is really, really nice. I like it a lot. Scala has something called ScalaCheck, which is kind of a port of it. Erlang has a QuickCheck port too, which is commercial. However, Crest and Crab Toolrope have created a Erlang that runs on top of the JVM called Erjang, and he's also ported QuickCheck. So you can you can use Erjang to write QuickCheck tests that test properties of Java, if you want to. Now, the interesting thing about QuickCheck is that you specify properties that should hold for a piece of code, and then the framework kind of is in charge of supplying test data and tries to break that property. And this works really well for certain kind of things. You can basically establish invariants and then have the testing framework try to break that. And a good example of this is actually, so John Hughes, the creator of the commercial QuickCheck version for Erlang, he used it to find bugs in C code, because Erlang has a foreign function interface, so you can call out to C code. And he specified some properties that should hold for that C code, and he managed to find several different bugs by running it on C code, which is quite a nice example of polyglot testing that is outside of the JVM. You can definitely go those kind of directions too. So there are a few different approaches you can take. The first one, and maybe the easiest one, is to just do exploratory testing. Exploratory testing generally refer to the practice of firing up the full application and then start doing things at random and try to break it or so on. But what you can do when you have a dynamic language or a language with a REPL, you can actually do exploratory testing on the unit level too. So you can fire up a REPL, you can load some Java classes, so you can start calling functions and methods and see what happens and see if you can find corner cases. This can sometimes be a really good way of exploring an API. I usually have a JRuby console open so I can explore the Java classes, the Java class library, because there are so many corner cases that isn't really covered with the Java doc. And I used to have this big directory with hundreds of Java class files where I have like 2 or 3 lines of Java code and a main method, because I wanted to test, like, for example, some of the corner cases of the regular expression library or something like that. But loading that up in JRuby instead is so much easier, and you can just continue exploring and see what happens. So that's a really good approach of kind of just starting to explore code. You can do unit and functional testing with it, just general using RSpec or test unit or anything like that. But you can also do higher level acceptance testing like Cucumber. So imagine that I have a Java class called PrimeFinder, where I create a new prime finder from 10, and then I say that the next prime should be 11. Prime finder from 25, pf.next should equal 29. And this is just a Java class. And if you run this file under GRuby, it will just work exactly like testing irregularly in RSpec. Or this example of kind of a quick shake approach in Ioki, where I say that for all natural numbers n, prime finder from n, pf next should be odd. This should very quickly find a failing example. Okay, so the second gateway drug is build scripting. Because sometimes having AND being Turing complete is not the most fantastic solution. Or doing Maven is not a fantastic solution either. So, I mean, in some cases, these build systems are the best way of building your system, but sometimes you need something more. Is AutoTools the best way of building C systems? Well, I don't know. It used to be, but it's pretty horrible nowadays. So there are some alternatives there. There are specific build systems that are geared towards building other languages. BuildR from Apache is one of those examples, which kind of combines Ruby's rake style with Maven's dependency management. Gantt is basically a groovy DSL on top of Ant. Polyglot Maven allows you to describe your POMs in different languages, which is also kind of nice. Sconce is it's a Python system for replacing AutoTools, so it's mainly geared towards building more low-level things, which is interesting because, as it turns out, since Sconce is actually only Python, it's less polyglot than AutoTools, which is a hodgepodge of lots of different macro systems and so on. But generally, you can also just use any language to build a build script. A person that should go unnamed from the Scala community once recommended me to replace all my Ant scripts with Haskell. I didn't actually do that at the time. For some reason, it didn't seem the right approach. So this is an example from the Gantt homepage. This is basically just Groovy code that will do the same thing as, I mean, you can kind of see the Ant tasks shine through here. You can kind of understand what's going on. One of the interesting things that happen when you're working in a language is that you can do things that are a little bit cleaner than doing them in Ant. For example, the clean pattern. Another thing that I like is that you can add dependencies inside of the targets instead of having to specify them here. So you can do quite a lot of nice things. I mean, you can do loops, and one of the common examples that happens in Rake is that you usually do meta programming over the Rake tasks to kind of define stuff. So the third reason you would use Polyglot Programming is to get access to libraries that isn't available. Now, for a Java programmer, this might be a reason for using GRuby to get access to Rails. Or if you're using Rails and you need to have a cross-platform subversion library, that might be a reason to run on a GRuby, because there aren't no cross-platform subversion libraries, as we found out when we started building Mingle, our product. And yeah, graphing also turns out to be one of those things where Ruby kind of has an annoying situation. If you want really advanced graphics capabilities, just go with GRuby and Java 2D. It makes your life so much easier. So basically, the idea is simply that you consume one library from one language by another language. And there is really nothing weird going on here. One of the things that really pisses me off about this approach, if you use statically typed languages, is that the build process becomes a real pain. So, as an example, I created an experimental language called Ioki, and Ioki runs on both Java and C#, and I initially built the C#, the .NET version using both C# and F# because I had one specific piece that was really well suited for a functional nature of F#. So it turns out that if you have a C# program that wants to use an F# component, you get this problem because you usually will have circular dependencies unless the F# component is really, really, it's not connected at all to the C# code. Now, my F# code really needed access to basically all the things defined in the C# code, and the C# code needed access to what's defined in the F# code. And what you end up having to do is is to break up the whole thing into 3 different DLLs. The first DLL defines everything plus an interface. The F# code has to implement that interface, and then a small DLL that actually ties the implementation, the F# implementation, together and injects that into the rest of the application. So instead of having 1 compilation step, you have 3 compilation steps. I don't know if Scala has fixed this yet. Do you know?
Yeah, Scala has fixed that.
Okay.
You have circular dependencies between Scala and GRuby. You can do that as well.
Yeah, sure. But GRuby doesn't really... I mean, you can get around that in GRuby easily because... yes. You won't have to compile GRuby, so you can always run GRuby afterwards.
Right. If you want to compile it.
Yeah.
If you want your Java code using GRuby classes, those have to be compiled.
Yeah. But this problem, GRuby is a weird case because GRuby has some kind of, some static annoying things without giving you any static benefits. But most, that was mean. The complication of build process usually happens if you have 2 static languages and if you're not just using a library. If you want to combine 2 languages, that becomes really annoying. And there are ways around that. Dependency injection as a pattern, not as a library, is usually a good way around it. Or the only way to really solve it in a good way, unless you want to kind of create a cross-compiler, or not a cross-compiler, but a joint compiler. But all of this stuff kind of depends on how integration works between the 2 languages. So this is a small closure example. It uses a very powerful Java library, Java lang system, to get the properties. It's not a very advanced example, but it kind of shows the approach, and this could be any Java library. And that's true for most of these examples. Most of the polyglot environments, you can definitely use exactly whatever is available on the other side very easily. So dependency injection, service injection is actually a quite useful approach to have when you're working in things like this. And the basic idea with dependency injection is that you just provide interfaces or something like that, and then you never mention real instances until you have to wire up the final application. So this actually works quite well in terms of composing. As an example, Spring has this thing called a script factory that allows basically an implementation of an interface in any language without having to use the language's integrations feature. So in this example, I have an interface animal here, and I have a Ruby class, run. Note that we're not using GRuby's integration features here. We are not implementing this interface at all. But with this lovely XML, we can make sure that the implementation of this file will be exposed as that interface. I know. I prefer this. In fact, I'm thinking about implementing a refactoring to kind of turn the GRuby implementation to something like this. One very old school, venerable way of working with polyglot programming is end-user scripting. Basically, you can start out by making it possible to customize behavior. This is basically a glorified configuration file if you start there, but you can take it longer. You can allow saving and loading of scripts. You can expose a model to the scripts so that the scripts can actually do things with the application. If you do that, you really need to think about how much of the application can be implemented like this. A good example is most of the current games. The game industry has done this for a long time. Most current games are implemented in a low-level language like C or C++. But most of the actual in-game stuff is implemented using a scripting language. Lua happens to be the one that most companies choose nowadays. I think World of Warcraft is a good example of something that is like 60 or 70% Lua. And you can do this if you just make sure to expose enough of your application to the scripts. And a good way of doing that is starting to think, okay, which pieces can I actually do to scripting instead of doing it through the core language? If you want to expose end-user scripting, you need to think about versioning. Most people don't think about versioning of scripts, but evolution becomes a really tricky thing if you don't do. If you take this approach of end-user scripting to its logical conclusion, you get something like Emacs in structure. Emacs, yeah. So Emacs is basically maybe 2 to 5% C, and the rest of it is Emacs Lisp. Basically, the whole editor is available as Lisp and can be overridden or recompiled or changed at any time, which is extremely powerful. In fact, I still think it's the superior editor environment available. So another side of this, of composition that I haven't really spoken that much about, mostly the things that I've mentioned now is kind of in-process things. But you can also do it at a higher level where you basically just work at a service level, a service API level, and just make a division and implement the services in different languages depending on what you need to do. Now, one of the things that can become tricky there is if you want to have a shared model, for example. Or if you want to have a shared database, then you just need to make sure that the way you work with it, you have transactions going and things like that. Or you just use an exposed model on the JVM, but use different JVM languages for different services. Another thing you need to keep in mind is that most of the time, if you're running one process, you want to have one controlling language, one driving language. One main method language, so to speak. In Ruby, for example, the way I usually do GRuby applications that need to do something really weird, then you have to basically have a Java main method that immediately shells out to Ruby and then gives control to Ruby. But you still need Java to kind of take the initial tack there. Another good example of that is like servlets. To do filters and servlets in JRuby, the way the JRuby servlet works right now, I think it still works that way, is that you have a very, very thin Java implementation that then basically just dispatches out to Ruby immediately. But you usually have to choose who will start the process, but also who will run everything. And those two are kind of different, because in most of these examples, Ruby is running, but Java is the one starting. But the one that's running should usually be the more powerful language. So it becomes easier to use metaprogramming and those kind of things. And it's easier to use Java from Ruby than it is to use Ruby from Java. And I've seen that is generally the case in terms of language power. It's easier to use the less powerful language from the more powerful language. Usually, this comes from several different factors, but the main one is that you have access to more capabilities, more things that you can't do in the lower level language. And it really actually makes a big difference, but in some cases you don't really have a choice. This is one of those areas where you want to be strategic. Okay, so there are some things that you need to watch out for when working like this. I mentioned the architectural patterns. One of the things that happens is that you generally end up with more than one language in a file. HTML, CSS, and JavaScript is a good example. Add 2 templating languages at different levels, and you have 5 languages in the same file. That's something you really don't want. So try to be smart about this. The big architectural pattern that happens if you're not strategic is called big ball of languages, which is a variation of the big ball of mud pattern. Basically, if you just use it willy-nilly in different areas of the application, you can end up with an application with 20 different languages that are all kind of shelled out to at different places. This can happen quite often if you do things like use shell scripts or something like that. You can end up with just having something that does an execution of a shell script somewhere in your application. And it's really tricky to find that place when you really need to. Ruby is a really, really bad citizen in terms of those kind of things, especially when it comes to shelling out. one thing that people don't think about as often is impedance mismatch between the languages. A good example is if you have to use C and Ruby together, where C doesn't really have any of the object-oriented features. If you've ever done a C extension, you will find that it's really verbose and annoying to work with it. But an even trickier example is the language I've created called Aoki is a prototype-based object-oriented language. And it's a pure prototype-based, which means that everything is an object, and dispatch is done by looking at the current object, seeing if it has a slot with that name, then look at the parents and see if they have slots of that name, etc., etc. Now, if you want to integrate Java integration into something like that, you have a problem. Because the way Java dispatch works is that you have an object, you go to the class, and then you start looking for the implementation. So that side step there is really, really tricky. And you really need to have it. Because how else would you handle something like static methods on classes? So Java actually has two namespaces that you need to separate in some way when working with them, while Aoki only has one. And that's a pure impedance mismatch between the languages because of the way, because of the power and because of the structure of the one language. And this is something that we don't really think about that often, and we sometimes can use to win by using the other language. But it can also cause trouble in terms of how you design applications. So just something to be aware of. When doing polyglot programming, what platforms you use really makes a big difference. At the moment, Java is definitely the best platform for doing polyglot programming. Java has some problems in terms of the current stewardship and the current... and also if you look at what's happening in the JCP, which is kind of sad. On the good side, things are happening on the Java platform, making it a fantastic place. I'm personally a member of the expert group for something called JSR 292, which will come in Java 7 in August, which will give capabilities to the JVM to do dynamic invocation as part of the JVM, and also method handles, which basically gives you a combinator-based library on top of pointers to methods, which makes it really, really powerful for all kinds of language-related tricks. Now, .NET is also a fairly good platform. The DLR gives you lots of capabilities that are fine, and they have approached F# like a full real language, which means that it's got Visual Studio support and all that stuff. However, it seems like the kind of the language-based thinking on the .NET platform is not as it's not as advanced, at least not in the open source community. So if you look at the JVM level, you have about 250 languages that you can use that people have released, and people are doing that kind of language-related stuff all the time. You have Antler, and you have lots of other things that makes it really, really quick to get started on the JVM. Many of these things are not as advanced on the .NET platform yet. Parrot is supposed to be a good platform for this kind of stuff. I think that last time I heard anything from Parrot 6 months ago, they were starting a complete rewrite. And I'm not joking, sadly. So I probably wouldn't recommend doing anything on Parrot for any kind of business application. Android is kind of the up-and-coming. GRuby runs on Android. Scala runs on Android. But there is some problem since most of the current JVM languages are based on bytecodes. And if you do bytecode weaving at runtime, that won't work on Dalvik because it's a different bytecode system. But slowly, surely, things are coming there. The big problem for Android right now is that runtime reflection is really, really slow, which makes these languages not as performant as they should be. Both iOS and the regular operating system for Mac uses Objective-C as kind of the lingua franca, and most of the APIs are using Objective-C. There are things coming like MacRuby and other language, and Apple has kind of been hinting that they're interested in going towards these kind of approaches, but I haven't seen much polyglot programming happen on Apple's platform so far. LLVM is a compiler infrastructure kind of set of tools that will allow it really easy for you to make low-level languages with runtime optimization and jitting. Right now, there's really not much in terms of there's really not that much of any kind of polyglot infrastructure that makes it easy to talk between languages right now. It's more a compiler tool chain to make it easy to make languages. But it's possible that this will turn into something that will change. V8 is actually turning out, and JavaScript is turning out to be more and more of a polyglot platform, both through things like Node.js, but also JavaScript in the browser, where people are putting languages over and over again on top of JavaScript because JavaScript is so horrible. As a good example, Rails, the next version of Rails will actually ship with CoffeeScript, which is a very, very good addition to the stack, I would say, and it really makes JavaScript much less horrible. libc, etc., you can do language interoperability between different C libraries at that level if you want to. It's usually tricky. You usually have to do that through foreign function interfaces that are not very nice. But I have done examples where I've exposed like Haskell functionality and used that from C and from Ruby, and it works. It's clunky, and you have to be really careful with the build processes, but you can definitely do it. So language interoperability is one of those things that you need to keep in mind too. How are you going to handle it? Sometimes you actually don't need it. But most of the time, you need to have some way of kind of calling out to the other language to kind of combine the results from them. One way is the service way. I don't have that on my slides, actually, I realized. But one way is just to use RESTful services and use JSON or XML as kind of a common data interchange format. A very common way traditionally is to just do string templating, the SQL way, where you basically embed small snippets to execute that can then go away and execute that into a real runtime engine. There's also JSR 2.23, which is the JavaX scripting package in Java, or BSF, to kind of get a more structured interoperability level. You can use GNI on the JVM to interoperate, or most languages have foreign function interfaces. But in general, all that stuff is kind of annoying, and I've noticed that in most cases, on the JVM, I just call in directly to the actual language implementation. It turns out that these things are more useful if you want to allow several different languages to provide functionality, and you don't want to build in a specific dependency on a specific language. There is also this thing called a MOP, a meta-object protocol, and this is an idea from CLOS, from the Common Lisp days. And Attila Szegedi has been starting work on something like this for the JVM. The basic idea is a MOP kind of provides an interoperability level where you can, for each language, you define what that language should do for specific MOP operations. So invoking a function, invoking a method, sending in a block, how should that look? And then there is a translation layer between the MOP and that specific language. DSLs kind of fit into this quite a lot. That's kind of the top level of the language-oriented thinking, the polyglot way of looking at the world, but I'm not going to talk about DSLs at all. I know that Debasis is going to talk about that tomorrow, I think it is. Tomorrow. So if you're interested in DSLs, Debasis is the person to go to. And I think that leaves us with some time for questions. Yes?
Well, I was wondering if you could give us your advice as a polyglot programmer. I mean, as a programmer who's comfortable with a few programming languages and has gotten very good at using it over the years, what are your ideas of when you make the trade-off to actually bite the bullet, learn the other language, learn another language, go through that ravine of productivity, versus when do you look for that nice, ideal, seductive polyglot interface where you don't do everything you want for your own language, you get all the cool functionality in your language. How do you make those decisions on when to go sort of native versus going to polyglot?
I would say, I mean, there are two things. Feel the pain. If you feel pain from your current approach, investigate. But also do exploratory. I mean, like a good way of doing this is testing and building, because you can. It's very little effort to set up something small that gives you that. And if that works, you can keep a parallel build going for a while. And then if that seems to work better, you can go that direction. Many of these cases, the effort to put up something really simple is actually very low. I know that one of the things that happened a number of times is that we have been engaged to do a Java project, and we've done that, and it's been horrible, and everyone has been miserable. After a few suicides, someone kind of decided to do an experimental Rails application that used the existing libraries that we created, did that in a weekend, and we kind of just went in and replaced. So it's really all about what your current situation is in terms of how much pain your team is in, and also it really helps if you already have experience with the language. I highly recommend people to learn languages recreationally. Because then when the time comes, you know that, oh, wait, this seems like a perfect Erlang problem. Maybe I can finally use that book I bought a while back. I think that having a few languages as quivers in your, as arrows in your quiver is actually a good thing, and something all programmers should have, so that when those situations come, you're ready to kind of give it a try. Any more questions? Yes?
In order to convince management to allow polyglot programming, I think you put together an argument that says, here are the benefits that we get, and on the other side, here is a reasonable estimate of the cost, the difficulty of hiring people who know this for training level, whatever.
Mm-hmm.
Where do I get numbers like that to make that case?
Yeah, that's tricky because it depends. I mean, it basically depends. Right now, it's still in its infancy. I mean, there is definitely... I mean, in terms of hiring people, that's always what management is afraid of not being able to do. That's always a tricky argument. I don't have a pat kind of blanket answer to that one. Yes, Bruce?
One of the things that you can do, my name is Bruce Day, and my co-cover was on the first slide. But I think that one of the things that you can do is talk about what you're deploying and keep the focus there. Because a whole lot of the languages that we use every day anyway already generate bytecode, and introducing one more sometimes isn't as difficult if you talk about all the other things that are already in it. Does that make sense?
Yeah, I mean, one of the things is to just approach this like frameworks. I mean, adding a new framework, do you have to make a business case to your management for that? In most cases, you usually don't. Okay?
But I don't have to go about doing that.
Yeah.
I can describe the benefits of a given framework.
Okay.
So I'm usually asked to evaluate how hard it is to learn the framework.
Yeah.
If I were the devil's advocate for a moment here, you've got, you made 2 points that are really, really interesting. You talk about how learning a language is roughly analogous to learning a framework. And it's really not any more difficult than that. It's the same framework, or the same language in the framework. But you also pointed out SapirWhorf hypothesis, where the language is shaping the way you think. And so on one hand, you've got the language is just a framework. It's just generating bytecode. On the other hand, you've got it's changing the way your mind works. Which is it?
Well, it's both. I mean, like for a typical example is monads. There are ways of working with monads in Java with kind of at a framework level. They are not as visible. They're very, very hard to pick up that way. And you kind of have to already know them to see the structure. But they are there in the framework. So, I mean, the language features are there, but I think that in languages, they're more distilled. They're more visible. I mean, the whole idea of a language is basically to make something first class, to put something straight ahead of you, in front of you, without putting a lot of cruft around it. So I would say that, I mean, to a degree, yeah, I mean, I see your point, but on the other hand, it is roughly analogous. It's just that in terms of frameworks, you're working within the confines of the paradigms that your current language gives you, while a language designed for a specific thing will just show it more clearly. Yes?
Do you have a sense for whether or not the academics, the universities, Are the kids coming out of school now are more used to polyglot programming?
I'm currently, the last few weeks I've been doing lots of interviews and recruiting, and I'm currently very depressed with what most schools are doing. Most schools seems to be teaching Java exclusively nowadays, and not doing a very good job of it either. So I would say no. On the other hand, the academic community is definitely more and more coming around. I mean, to a degree, the academic community has always been promiscuous when it comes to languages and making changes to languages and kind of using what kind of works for displaying that specific thing. But I also know that the communications of the ACM and the IEEE have both kind of had specials about polyglot programming quite recently. And there's also at Uppsala and Splash, there has been more and more polyglot kind of coming out at that kind of intersection between academia and industry. Yes, Daniel?
Yeah, and so I think we need to distinguish between academia as in what people are publishing and
Yeah.
researchers are doing and what's actually being taught to students. Because we talked about how hard it is to get management to the business to accept the new language. Multiply that difficulty by like 1,000 times, and that's how difficult it is to get a new language into academia to actually teach students. I mean, a university that I'm attached to just recently switched away from C++. So it's horrific how many barriers there are for that. So it'll be a long time and effort before polyglot programming is taught to students, to undergraduates.
Well, as it turns out, things that we've been doing in the industry for 10, 15 years are just not common practice in teaching right now, which is kind of sad. But it seems, on the other hand, what's published is definitely keeping up much more. Okay, just so people know, there is lunch now, so if you don't want to stay, that's fine. But I think there were some more questions. Yes?
I guess my question is, to what degree do you need to design, say, like your core services and libraries to be consumed by other languages? Like, say, for example, like a Scala library will barely give like a set of big ass jobs. So, to what degree do you have to keep that in mind at every level, or are you coming up to that not to be the case?
Well, to be honest, I mean, the kind of projects that I work on is usually fairly agile in terms of how we run it. So, which is basically the last responsible moment to do things like that. So, and what I found is that designing something big up front is usually not a good way of approaching. Instead, adding things to the lower level when you find you need them from the higher level, and if possible, make sure to try to implement it in a high-level language first, and if that becomes a problem, then you can kind of sink it down and kind of cement it into the static language. Yes?
I would like to add, comment on that, at framework. It's a perfect example where you can use it from Java seamlessly, and within that framework, you can use it fully stuff. Transparent application stuff. So I think it's a perfect example of this polyglot stuff happening.
Yeah. Yeah, but an interesting thing to add there is that there's still no. So one of the kind of litmus tests of what a Java replacement language would look like is that you should be able to implement all the Java core libraries in that language. And there is still no language I know of that kind of fulfills that completely in terms of exposing all the functionality of what you can do in a way that means that all other languages can do it. Maybe you can do it with really contorted Scala, but yeah. Yeah, so I mean, and that's kind of what, when you look at languages like Fan, for example, and those kind of languages are looking for, or Salem for that matter, I mean, they're aiming for that spot like Java++, where it becomes a little bit better, but you still have all the capabilities of the JVM available to you. Because at the end of the day, if you go to something like this, the JVM becomes the kind of lingua franca, the interoperability level. And it's a really good place to be, except for certain corporations. But yeah, it's so you have to think at the JVM level, not at the language level once you start doing interoperability like that. Okay, thanks for your attention.